Hey guys, Dave with Fitness Technology Services here. So today I think I'm going to do a video. It's going to be on the same thing basically about walk belt wear, but I'm going to do it in a way where you can really understand what happens with it. So what I've done is I have my meter hooked up and I've put two inline fuses on my motor because the breaker and fuses that a treadmill comes with are basically on the AC side. So we need to think about protecting our motor and the input going to the motor controller. So I think it would be a lot cheaper really if you put a 10 or 12 amp fuse in it. The unit's usually set up to hold 15 amps. A lot of times it's even recommended that you have it on the 20 amp circuit. But I think really to try and save the motor controller and to test and see if your walk belt is worn, I think a 10 amp fuse would, in line with it, would kind of serve a really good purpose. If worse comes to worse, you'd have to replace a $2 fuse rather than a $250 motor controller because your walk belt worn. So what I'm going to hope to do is turn this thing on. I did it earlier today, but I did it with only 1 amp, so of course that blew. But right now what I have in them is 6 amps. I don't like my treadmills to pull more than 6 amps during a casual 2 or 3 minute walk. That's kind of how I test them. You'll see I got a lot of videos out on that. So I'm either going to blow my motor controller, which I really don't want to do, or I'm going to blow the fuse. And hopefully I got that at a good enough angle for you. So the first thing I'm going to do is I'm going to hit start, of course, like anybody would do. Alright, so the connection's good enough to at least get the treadmill to run. Then I usually like to run everything around 3 miles an hour. So it takes a long time at one at a time. So that is 3.4 miles an hour. So we'll let the meter catch up to it. And you can see with nobody on it, the actual electronics, the pull on the electronics, the motor and the controller and the wear on the rollers and everything added into it is less than 1 amp. It's 0.75, 0.76. So that's really good for an older machine. Now you don't know what kind of controller I have in it, but I do have an older controller. I'm even using a controller out of a smaller model because I want to blow up a controller for my F80. Alright, so now, we're looking at 3.2 miles an hour. We're running around less than 1 amp still. So I'm going to walk on the outside edges like I always talk about, and we'll see what kind of readings we get. Alright, so we're going to see if we're going to blow my motor controller or hopefully blow my fuse. Alright, so hopefully you'll be able to see that a little better. That's 3.9, I'm going to go down a little bit, 3.4, put my pointer away. Alright, can you see that still?
Yeah.
Alright, so I'm going to walk where it says sold, and you tell me what kind of amps that is. Looks like it's 4, 5, yeah, very good.
3,
Alright,
4.
and it actually feels pretty good as I'm walking on it. It feels smooth. I don't feel any wear. Now let me walk in the middle.
Whoa.
And boom. Now what did that do? I didn't even get to take 2 steps in it. So if I didn't have this fuse set up in the middle, look at that, the famous LS1 error that everybody hates. If I didn't have this fuse set up in the middle, that would have blew my motor controller. So the condition of the walking belt really controls the operation of the treadmill, really. So if you're walking on your machine and it shuts off on you and you get the LS1 error, you could have blew your controller. I mean, it's very possible. Sometimes the controller overheats, just shuts off until you let it cool down and you can use it again. But I just wanted to really use this as an example on how you should either protect your motor controller. You really got to change this belt. Now if you look at this belt, I have this belt in a lot of other videos. It looks perfectly fine, but underneath of it is wore out. So that's a pretty good example. I hope everybody enjoyed that video. I'm really stressing on everybody, when you buy a motor controller, the reason why you're buying it is because your walk belt is worn out. All right, so again, this is Dave with Fitness Technology Services, and I'll be doing another video soon. Thanks a lot. All right, so one last little test. I have a 10 amp fuse in here now. Like I said, I usually don't like it to go above 6, but I'm going to test this at 10. I'd like this fuse to trip before my controller goes. That's kind of what this whole test is. So let's see, with 10, I should be able to walk on it a little longer. The last time I did this, it was with 6, and I couldn't walk on it very far before it blew it. So I'm going to take it back up to 3 miles an hour. Should I turn that light off?
Yep.
Well, once it gets up to 3, I will. Takes it forever. That's called ramp up time, ladies and gentlemen. That's what it does. Nice and safe that way, though. 2.8, 2.9, 3.2. We're going to cheat a little bit by 0.2. All right, so what we're going to do now is, again, I'm going to walk on the edge, and then I'm going to walk in the middle, and let's see where it blows, all right? So again, it doesn't feel, I'm going to up that a little bit to 3.5. All right, so it's got a little drag on the belt. I don't really feel like it's going 3.5, so there's a little drag, but again, on the sides, not much at all. Now let me walk in the middle now. Let me turn this off. All right, I'm going to walk in the middle now, and you can really hear the struggle. So with a 10 amp fuse, hold up. So that's a little better. I'm getting a couple minutes out of it at least. So what is my meter saying? Can you read that?
It's hard to see.
Yeah, you can't really see that. Let me turn this on really quick. Make sure we got
Yeah, I
it
can
over
see it
here.
now.
Okay, you can see that better?
I could, yeah.
Up.
No, that's fine.
You're right there? All right. Wow. 9, 8, up. There you go. Didn't take much. Hopefully you're able to see that. I had the light on, but I think it flashed enough. So the bottom line is, guys, I just blew a 10 amp fuse. It is a 15 amp controller, a 15 amp system, but you really don't want to take it up to that, because instead of your fuse blowing, your motor controller will blow. So I think this is kind of proof positive that once your belt's worn, as you notice, I can walk on the outside edges, pulls 3 amps, 4 amps, pretty normal number. Walk in the middle, get to the point where it's pulling 7 and 8, get to that 10, trips that fuse. If that fuse wasn't there, that would have tripped the controller and cost me more money than what to spend, really. All right, so I think that's going to be it for that. I think you guys got a good idea. I have these fuses hooked up both on the negative and positive side of the motor. Doesn't seem to really matter that they both blow equally, it seems like. So this is really proof positive that you need to change this walking belt and keep those amps. Again, I like them under 6. I guess we'll settle for 8. But when you get to 10, you're getting very close to blowing this, and I'm only walking on this for a few minutes. So if your workout time is a half hour, 45 minutes, you're going to blow that controller. All right, so that's all I really got for you. I just wanted to add that to the other one, ending it with 6 amps. I didn't think was really enough. Didn't really make enough of a difference on it. And I think with 10 amps showing you that it blew, hopefully you could see that with the light. That's all I really have for today. Thank you so much for viewing. Hopefully you guys find this video helpful. And thanks a lot for all your support, all right? See you next time.